Thank you for joining us. Here we have a new speaker, Swastika Yadav. He's going to be talking to us about the power of edge computing and why it really matters. Please make them feel welcome.
Hello everybody, thank you for being here. I know there are many amazing talks going on in other halls, and you all being here means a lot to me. So today I'm going to talk about edge computing. So how many of you know what edge computing is? Okay, a few. So I hope the number goes higher by the end of this talk. So here's a little context about myself. I am Swastika, and I work as a developer advocate at Nunch.io. It's a backend as service built on top of Kubernetes. And previously, I was working as a developer advocate at Torso database, which is an edge database. So that's how I got into edge database. I also create educational content on platforms like Twitter and LinkedIn. And hopefully, by the end of this year, I'll be adding public speaker to my introduction. So this is how the agenda looks for the talks. We'll be seeing what is edge computing, how it is different from cloud computing, what are the use cases of edge computing, and how one should decide if they should go with edge computing or cloud computing. So a lot of my friends who have been to the US always shared how fast the web experience is in the US as compared to the other parts of the world. And I majorly thought it's because of the high-speed internet, or maybe they have a better technology. But what does actually happens if we need a great web experience? So for example, if we click on a particular link, user sends the request to the server responds and transmitted the necessary data and sends the request back to the user. And the time taken in this process is basically depends on three things: the speed of your internet, processing time at the user's end, and the cloud center's end, and the most important thing is the time taken. Okay, so shall I remove that? Okay. And the most important thing is the time taken by the data to travel from cloud center to the user and back and forth. So because most of the data centers are anyway placed in the US, so the speed and the web experience is way better in the US as compared to the other parts of the world. So edge computing is one technology which can help people to have similar experience with web interaction even if they are in any part of the world. So edge computing is kind of similar to cloud computing with one major difference, that is centralization. So in the case of cloud computing, we take computing to the cloud centers, while in the case of edge computing, we take cloud centers closer to the data where the user has created the data. So we'll see which will directly decrease the latency. So here are the two tools which can show what is the difference in the latency. So this is a tool by Vercel where you can, how do I click on it? How do I click on it? No. Okay. So if we just choose a data service here, so the blue line shows the traditional cloud computing latency when the data is directly taken through the US, while the purple line shows the edge computing functions when the data is processed at the edge network. So you can see there's a huge difference in blue and the purple lines. And it's not switching back.
You want to go back to the other window?
Yeah, the main one. So here's an example of latency difference between the USA and India. So on the right-hand side, we have the latency distribution in the US. You would see there's not much of a difference in the blue and the purple line on the right-hand side, because even if we take the example of cloud computing, the data center are present there only. So it doesn't make much of a difference in the latency, while on the left-hand side, you'll see the latency distribution in India is way different, and there's a huge difference between purple line and the blue line, because the blue lines is showing the data which is transmitted through the US, while the purple lines is processing the data through edge computing, when the data servers are present at the place where the data has been created. So now we have another tool. It's not. Yeah. So if we switch it off, this is a tool by Torso database. If we switch it off, we can see the data centers are present in the New Jersey, and the latency is way lower than any part of the world as compared to the US. And if we switch it back, so now we see there are multiple data centers present, which are like replica of data centers created locally where the data has been created. So you can see there's a huge difference in the latency in the other parts of the world as well, as compared to the one in the cloud computing. So the key components of edge infrastructure. So in edge infrastructure, there are basically two main components. One is edge devices and other is edge data centers. Edge devices, you can think of them as a hardware which manages the flow between the server side and the users. So it manages the boundary between the networks. So for examples, IoT sensors, smart cameras, or processors are few of the edge devices, while the edge data centers are the smaller data centers which are created near to the users where the data has to be created, and it acts as, it delivers cloud computing resources to edge devices. Here's an example of how edge computing works in IoT systems. So here we have some edge devices. Data is transmitted to the edge network, and all the processing of the data has to be done here only, while only the results of this data has to be sent to the data centers for further evaluation and human interaction. Rest of the data is already been processed, which also helps, apart from reducing the latency, it also helps in high security, because if you have a sensitive data, you can process it at the network edge only, and the result of that data can only, the document or the data which is not that much sensitive can be anonymized, can be sent to the cloud centers, and rest can be processed here and sent back from here only. So cloud computing versus edge computing. So there are 4 scenarios on the basis of which we'll see what is the difference between edge computing and cloud computing. Centralization. So this is the major difference between edge computing and cloud computing. In cloud computing, we take the data to the cloud centers, and the data centers present at just one location, while in the case of edge computing, there are multiple data centers created around the world. Data distribution. In cloud computing, since the data center is present at just one place, all the data is, there's no distribution of the data. All the data is stored, managed, processed at just one place. While in the case of edge computing, the data is distributed between multiple data centers, and maybe some part of the data is also sent to the leading data centers. Data processing. So edge computing is way faster in data processing as compared to cloud computing, since the data is processed very near to where it is created. So it reduces the latency, it increases the security, and helps in providing an action-driven solution in real time. As compared to cloud computing, the data has to be processed at just one place, and it doesn't matter how far it is from other places of the world. It's going to take time. Real-time interaction. So the cloud computing and edge computing both follows real-time interaction, but in the case of cloud computing, it's not always possible to have real-time interaction because of the delay and the latencies. While in the edge computing, the chances of delay and the latencies is way lower than cloud computing. Use cases of cloud computing. So as I mentioned, there are the three main benefits of edge computing are low latency, real-time data interaction, and high security for sensitive data. So when we talk about low latencies, everyone deserves low latencies, and anyone and in any part of the world deserves low latency. So they can achieve that latency with edge computing way easily if they have local data centers near to the place. While in the case of cloud computing, the data has to go to the data center. In present, most of the data centers present in the US only. Real-time data processing. So in devices like IoT systems or autonomous vehicles, there are like hundreds of different edge devices which require to process data. And the massive amount of data has to be sent to the cloud server, then it is sent back to the edge devices, which is a time-taking process. So in the case of edge computing, that data is processed at the place of edge data servers, which is very near to the place where the data has been generated. So it also helps in it increases the speed at which the solution can be provided or a response can be created. For data privacy, again, sensitive data can be processed and analyzed locally at the data centers, replica of data centers present near to the users. And while the anonymized data can be sent to the cloud, which does not contain that much sensitive data, and so the sensitive data can be processed from the local data centers only. So to decide between edge computing and cloud computing, it's not something like they are not interchangeable technologies. Both have different purposes, and we need to decide on the basis of what kind of product we are looking for, what are our requirements, what's going to be our need in the next few years. So for considerations for cloud computing, so there are three main considerations, that is data volume, data sensitivity, and latency requirement. So if the data volume is huge, so it would be difficult for small data centers created near the users to process that much data and send it back to the users. So in cases of maybe like a healthcare system or financial system where a huge amount of data is created every day, cloud computing would be a better option, because even if it is slower, but the data complexities and solutions would be more reliable as compared to edge computing. Second, data sensitivity. If you have a sensitive data where data breach can be a problem, in that case, cloud computing is a better option, because it anyways, you can process it locally. You do not need to send it to the cloud servers. So you can say, save the part where you need the main data. Latency requirement, again, edge computing decreases the latency by a huge number. So if you need a fast response, a faster web experience, edge computing could be the go-to choice. For cloud computing, scalability and intensive tasks. So as of now, cloud computing has been in the industry for a longer period of time. So it automatically has much more platforms or products. People are using it more as compared to edge computing. There are many more products on which you can build using cloud computing as compared to edge computing. So anyway, it's easier to rely on just rent a cloud service provider as compared to edge computing. For the higher intensive tasks where there's a lot of computational processing required or big data analysis is required, so again, that is difficult for smaller data centers to process that much data. And while in the case of cloud computing, they have bigger data centers where a high level of computations and data analysis can be done. Hybrid solution. So as of now, we do not have a solution where we can have a mix of cloud computing and edge computing, but there are a few companies who are working on that solution. So maybe in few years, we'll have a blend of cloud computing and edge computing, where we can get the scalability and reliability of cloud computing and the low latencies or security of edge computing. So these are the takeaways from the talk. Cloud computing brings server closer to the data, whereas in cloud computing, we take the data closer to the server. It's not a choice to choose. It's not our choice to choose between edge computing or cloud computing. There could be a reliable solution where we can get both the benefits of both the technologies. And still, edge computing is quite new, and very few companies are working on it. But maybe in the future, we'll have something where we can have a mix of both the technologies. Edge computing helps in reducing the latencies and optimize the real-time solutions, while in the case of cloud computing, it is suitable for companies or organizations where the huge amount of data is created, and we need to centralize that, manage that data every now and then. So it's difficult for edge computing to manage that amount of data. For that, cloud computing is a still better choice. Hybrid solutions could be a next big thing in the industry, where we can have the reliability of low latencies and have scalability of cloud computing. So companies like Vercel, Supabase are working on it. So maybe in next few years, we'll have a solution like that. So thank you, everyone. You can connect with me on Twitter or LinkedIn. And if you want to chat about cloud computing, edge computing, backend services, developer advocacy, I'll be happy to catch up. Thank you.
Our speaker has asked not to take questions at this time. Are you still? Okay, yep. Well, thank you very much for your talk. You've given me a lot to think about. And here is a mug and a thank you card. Thank you very much. And another round of applause for our speaker.